Okay, we're going to look at Simple Network Management Protocol, or SNMP. We'll review the terms and its operation, and then we'll configure version 2 of SNMP. And then in a later video or a later discussion, we'll look at configuring version 3, as the configuration is quite different in 3 versus 2. So with SNMP, we have what we call a manager. A manager is software running on a computer that collects agent information. Then we have, so now we referred to our agent. Our agent is software running on managed devices that understands information in the MIB. The MIB, or the Management Information Base, is a database of variables that describe conditions on a device. So for example, interface status. So if we look at our topology here, we have our two agents. Router 1 and switch 1 are our agents. Okay. Actually, I shouldn't say that. Router 1 and switch 1 are our managed devices. On those devices is our agent software that's running. And in there is going to be our MIBs, or our Management Information Base, our database of variables that can be collected about these devices. And then that information can be sent to our manager, who is software that will be running on a computer that will collect that information. And MIBs can be very complex, and we're not going to go through it. There's a hierarchy to it. I don't feel here that it's really necessary that we go through it as we go through the operation. Just know for sure, as you can certainly get in much more depth if you would like, but know for sure that it's much nicer to have a nice piece of software here that will give me some graphical information, as I'll show you. So how does it work? Simple basic configuration would be like a read-only. Okay, we have different types of packets that are sent, or requests and response that are sent. We have our GET, our SET, our TRAPS, and our informs. Our GETs are used to request information from the agent. So our manager, when we first configure SNMP, or when we do the very minimal of what we need to do with SNMP, will send a GET request to our agents. And then, it's requesting certain information that'll be in the MIB itself. In our case, our switch 1, which is running our agent, will then send a GET response. SET messages will be used to change device configuration. You need to be very careful with that, because obviously you don't want people to be able to change your device configuration if they're not supposed to be. But SET commands will be used to change that. So we use GET request just to request information. We use SETs to actually change device configuration. So this is kind of the manager pulls from the agent. Now what if the agent has something going on? So for example, in my configuration, I'm going to have some loopbacks that we can sit and do things with, because I want you to see them go up and down. So I've got a loopback 0. Let's say that interface goes down. We want R1 to be able to let our manager know that that interface has gone down. So he'll send a trap. So if we enable traps, traps will be sent, and we don't have to enable traps, but if we do enable traps, they're sent from the agent to the manager to inform about a condition. A trap is sent without an acknowledgement. An inform is the same as a trap in that, again, this interface goes down, and we're going to let our manager know about that. The difference between an inform and a trap is that an inform needs an acknowledgement. So the manager has to acknowledge back that it has, in fact, if we're using informs, he has to acknowledge back that he received it. And if he doesn't, within a certain period of time, if the acknowledgement isn't received, another inform will be sent. So our GET is used when our manager is requesting information from the agent. Our SET is used when we want to change configuration on the device. Traps and informs are both used when the agent wants to send to the manager. Instead of the manager requesting it, when something happens, our agent on our management devices want to let the manager know right away. And the only difference between traps and informs is that an inform requires an acknowledgement. A trap simply will send it, and it doesn't expect a response, and if for some reason the manager doesn't get it, it doesn't get it. Okay. We have three versions of SNMP. SNMP version 1 was the original version, uses community strings. Two types of community strings, read-only and read-write. We have to have read-only in there if we expect an agent to communicate via SNMP, whether it be version 1 or version 2. Read-write would allow those set commands to be done. So if we do a read-write, we would allow changes or writing to the device. The community string needs to be agreed upon between the manager and the agent. So in a sense, when we say we don't have any security, even though the community string is not good security because it's sent in clear text, it is like a password between the two. So the manager has to have the same password or community string as the agent has set. SNMP version 2, or really what we've standardized on, is SNMP version 2C. So when we refer to version 2, we're really referring to version 2C. It improved confidentiality and communication. It added a get bulk. It added the get bulk message and the inform message. So the original version 2, and why we said we ended up standardizing on version 2C that we now just kind of commonly refer to as version 2, was because the original version 2 security was kind of complex, and folks wanted to go back to this idea, the original idea of communities. Hence we got the 2C, which did then add that community, or went back to the use of communities as we did in SNMP version 1. And then later we'll look more in depth at SNMP version 2, but its main improvement was added security. It added some improvements to remote communication, but its big thing was that security that it added. And you'll see that after we do some of our simple SNMP version 2 configurations, and then in a later session do our version 3 configuration. So what does it look like to configure SNMP version 2? We have only one actually required command in order to configure it. And that's the SNMP server community read only command. So we do SNMP server community, whatever we want to call our community. Remember, we called that, we also kind of refer to that as a password because it has to match on both our manager and our agents. Read only, and I can hit a carriage return right here if I want, or I can specify an access list. And the cases I would specify the access list would be to add security, meaning if I had multiple devices on my system, if they knew my community string, any device could be an SNMP manager. If I only want a particular or a set of particular devices to be our network management system or to be our SNMP managers, then I would specify that in our access list and then call that access list here, whether it be v4 or an IPv6 access list. And then we have some optional configurations. Read-write, so the same thing, community string, but we can optionally do read-write, not required. We can specify the server chassis ID, and we can specify, who to contact. So SNMP server chassis ID, and then the string identifying the chassis, SNMP server contact, and who to contact. And then lastly, we can do traps or informs. This is under optional. Also, I wanted to separate it out because of the different kind of configuration. So if we want to specify in version 2 whether to send traps or informs, we do use the SNMP server host IP address. That's the address to where your agent needs to send the information. So it's the address of your SNMP manager. Version. Oh, that's not right. Yeah, that's not right. That's a typo. We could do, well, it's kind of a typo. Based upon the way it's written here, that's a typo. We could do SNMP server host IP address version, and then just tell it to use 2C. And then by default, it only sends traps because that's the default. We can leave it there. Based upon the way this was written here, traps or informs would need to be specified first, and then the version, which in this case is 2C. And then SNMP server enable traps, so enable all the traps that are available on that device. All right, so let's go ahead and look and configure it and see how it behaves. So here's kind of a simple network we have. We have our manager at 172.16.1.10. We have two agents, a switch and a router. The switch's management VLAN we just left it at 1. We made this very simplistic. And it's 172.16.1. Another typo, goodness. 1.2. So he's 1.2. And then down here, our router 1 is 1.1. So let's go ahead and configure it then. We'll start with something really simple. So the first thing I want you to see is my management software. And all I did was download a free version of NMS. If you have, there are some really awesome, great paid network management software. And for the purposes of this, I just downloaded the dude. Just give them credit here for helping me out with this demonstration. And I did a simple network discovery of just our devices. And this is our router and switch that we talked about. Discovers them via ping. But we can click on our devices, and we can see here, if I go to SNMP, so we look at just our general information. If I go to SNMP, what we see is there's no, there's no SNMP information here because I don't have it configured yet. So let's go ahead and configure SNMP on R1 and our switch. All right, so I pulled over the terminal window for R1, go into global config. All our SNMP commands are in global config. SNMP server, community, I named it lab, and read only. Remember, that's our only required command. We hit enter. We're going to go back to our network management software and see if we pulled any information. It might take a minute here. Don't forget that part. Here, let's go ahead and probe it. All right, so now when I hit a refresh, you can see now I have SNMP information. I don't have any routes because I'm really not running them. I'm running a router and a switch directly connected to our management station just so you could see. But we can see our currently configured IP addresses. I have a couple loopbacks configured in a 10.1.1.0 network, 10.1.2 network, and our gig Ethernet is 172.16.1.1. Now remember, there's a ton of things you can do with SNMP. We're just going with the basics and seeing how it works. So now, that is literally it for what you have to do. Let's go ahead and we'll just enable traps so we see an example of it. And then I want to show you one other thing. So the first thing I want to do is go over to our switch 1. He's not enabled for SNMP yet, so let's just go ahead and do that. SNMP server, community, lab, read only. So he'll be able to start pulling information. Let's enable our traps on both our devices so that if something happens, they can just send information. They don't have to be pulled for that information. So snmp.server host, and our management host is 172.16.1.10. And then remember, I can do traps or informs here and then version, or if I just do version, then all I'm doing is I'll enable the default traps. So we could do version. So I just go ahead and let's just hit a question mark so you can see it. So here again, like I said, you can either do version and specify the SNMP version, which will by default then it'll be set to send traps, or you could specify informs or traps and then do version. Let's go ahead and do informs. Okay, and then version, I'll hit a question mark, see. And version, we're going to do 2C. We could do any of the 3 versions. We'll do version 2C. Oh, I know what I missed. Let's go ahead and just hit our question mark. Forgot our community string. We kind of need that part, right? Remember, that's like our password that they both agree on. All right, so informs have been set on our switch. If you just wanted to do, you normally wouldn't do the same, going to the same, you wouldn't normally do traps and informs going to the same host, but I just want to demonstrate that by default we send traps. So if I do version 2C and our community string called lab, it'll by default then send traps. Let's do the same thing on router 1. So SNMP server host, I suppose I could have just done over here, huh? Version. Now we just send traps here. Oh, almost forgot the community string again. Right, and literally that's all there is to it. The only thing we want to look at next is, say, access lists. So if we've got a lot of hosts on our network, we want to make sure that, especially if we're going to allow read-write, we want to make sure that only our network management stations can pull information from our devices or can configure our devices. So let's do an example with an access list that specifies only that particular host. All right, so I added another monitoring station to our network. So now we have 2. I just did an IP config so you can see we have 1 on 172.16.1.12. And then we have our original uh, 1.10. Now all I had to do to add this was just plug it in, download my free version of the dude, install it, and if I knew the community string, I could go ahead and pull the information. And remember, community strings are sent in clear text, so it would be as simple as Wireshark to just pull up community string information. So now both of my systems are pulling information about my devices. If they're just regular users checking things out, not a big deal. But there's a lot of information that can be learned through SNMP. I think it's it's just not very secure, especially SNMP version 2, which is why we created version 3. But we can add just a little bit of security by creating an access list and saying, hey, this is my network management station. This station is the only one that's allowed to send GET requests, or that I should respond to GET request with. So I should do a GET response. This is within the host and informs, we specify the host to which a trap or inform is sent, but GETs can be pulled from any device that knows your community string. So let's go ahead and set an access list that says, okay, only 172.16.1.10 will I respond to their GET requests. So if we go into R1 and we create our access list, config T, we could do a named or a numbered access list. It really doesn't matter. We're going to stick with named because they have a lot more flexibility and we'll use them later. So let's do an IP access-list standard, because all we're doing is specifying an address to permit or to allow. And we'll give it a name. We're going to call it our lab ACL. Or how about if we call it lab_SNMP ACL? A little more descriptive. And then we want to permit host 172.16.1.10. Now he should be the only one allowed as soon as we apply it. So now we do this. We exit out. And then we do SNMP-server space community lab RO, and then we should apply our access list here. If we hit a question mark, we see that we can apply a standard access list, standard or extended access list number, or our access list name. We'll do our name, which is lab underscore SNMP underscore. If we go back to our network management station, it should lose its SNMP information because it's not allowed to get. Let's make sure we're on the right one first. It does look like it lost it, but let's make sure we're on the right one. So we click down our command prompt, we have 1.12, and in fact we have lost our SNMP information for that. So that just gives us one way of handling it, giving us a little more security. And we have not lost our SNMP on the host that's allowed to be our network management station. So that's it for version 2. We could go much more in depth, and network management software has a ton of options. These are just the basics to understanding SNMP. And in the future, we will look at SNMP version 3 or configuring version 3. The concepts are still the same. We still have our managers and our agents. We lose our communities. We do something a little bit different, but we'll look at that later. And that's it.